All right, I think we can get started. Hi, everyone. Welcome to another webinar. I am Rishav. I am an applied scientist here at Future AGI, where we are building a closed loop platform for you to be able to test your agents. So you can evaluate, test, and iteratively improve your agent all in a single platform. In our last webinar, we discussed how you can build a chat agent and iteratively improve upon your RAG systems. And as the world is currently moving towards a higher adoption of voice AI, today we'll be discussing how you can build voice agents that actually work in production. And joining us today, we have Jesse. He's a staff developer advocate at LiveKit, where he works closely with developers building real-time AI voice applications. Before LiveKit, he spent several years at MongoDB in developer advocacy and has been creating hands-on programming tutorials for developers for years. So, given today's focus on production ready voice agents, I'm really excited to learn from Jesse's experience and how some of the practical challenges that teams can run into when building these workflows. Thank you so much, Jesse, for joining us today.
Yeah, thank you for the introduction. Appreciate the invitation to be here. Shall we get started?
Yes. So before handing it over to Jesse, and he will be showing us a very cool demo and how to set things up for a voice agent, I'll just spend a couple of minutes on setting up the context. So as I already, just a minute. Maybe I'll just move on with this view for now. So as I mentioned already that the voice agent adoption has been increasing rapidly, and for the last few years and months, we have been seeing a growing adoption in voice agents, and it is predicted to grow year on year. And by the year 2034, it is predicted to reach about a 47.5 billion US dollars market. Right. So the adoption of voice AI agent is a new big thing that everyone's been discussing in AI. But for the companies who have been adopting voice AI into their workflows, only a very small percent are convinced about, productionizing these workflows, and remaining 80% range from very dissatisfied to somewhat satisfied. So not all the pilots and the experimentations that have been going on, especially with voice AI agents, always convert into a successful deployed production ready environment, right? And the most dissatisfaction doesn't come from cost or latency. Companies are ready to spend money on like good work AI workflows, and latency somewhat also have been controlled to a certain extent. But the biggest bottleneck right now that the companies are facing are with the quality itself. So the agents that they are deploying, whether the customer satisfaction rate are still high, whether it is solving the problems that the voice AI agent was supposed to solve, or whether it is able to handle different languages, different dialects well, right? And as we all know, and we have seen several such popular cases, when the quality slips, the pilot gets switched off, right? So there are several cases out there in public, such as the McDonald's drive-through AI test that they were doing, and certain other popular cases as well, where the pilots did not work out, and these systems had and pilots had to be shut down. So they never, got a widespread adoption. Now, there are several criterias that, buyers or people who are developing these voice AI agents, they keep in mind. It could be related to latency, as I already said, related to language and dialect. How well does these system integrate with their already existing systems? Right. And one of the biggest bottleneck becomes how do you test these systems at scale, right? Before you're putting them into the production environment, you want to test them for scale and evaluate how these agents are doing, and that is where a lot of issues start occurring and surfacing. So I remember like a lot of times when I am calling certain companies trying to speak to their customer service, I on the other hand there is an AI agent most of these days, and I get very frustrated with the experience that I have over there, because it doesn't seem to understand the problem that I am trying to describe. And after repeated escalations on how can, like, please connect me to a human, they would still refuse to do so. So it just enters a loop and the customer satisfaction really drops. So that is not the trade-off that the companies want to do. They, of course, want to adopt efficient workflows, but they, at the same time, they want to keep their customer satisfaction rates high and, get the task completed as well. So that is where Future AGI comes in. We help you ship AI agents that your customers can trust. We are building a closed loop platform where you can connect your agent and simulate several use cases, evaluate, optimize, add guard railings over them, and monitor them in production as well. So you can really take a failed trace, so your production traces that have failed, and simulate several different use cases from them, and then turn them into scenarios that your agents should work upon and iterate over your agent. So we'll see more of this later, but before that, I'll hand it over to Jesse to show us how to build an actual voice AI agent.
Yeah, I really appreciate that. A lot of the points that you just hit are points that I will make as well in my presentation. I'm going to try to go through these slides rather quickly because these will really set the stage for what we're going to build. But understanding these fundamentals is very important. So we will get to actual building and actual code in just a few minutes. But most of the agents that we build today, they do their work in the background, right? They write code, they run research. You give them a task, you walk away, you come back. Nobody really cares if a background agent takes an extra 10 seconds, an extra 10 minutes, maybe 10 days. These days, I don't know, does anybody have an agent running for 10 days straight? That might be costly, but those are the majority of the agents that we deal with on a day-to-day basis. But there's another type of agent, and that's what we're going to talk about today. And sometime in the past year, you've probably talked to one. Rishav said that he talked to one as well. I talked to one the other day when I called a car dealership. Maybe you were calling an airline or something like that. And so these are real-time agents, conversational, in-the-moment agents, not ones that we want to wait, seconds or minutes on. And so here's what happened. At some point in that call, you did the most human thing possible. You talked over it, it interrupted you. It fell apart. It didn't feel natural, right? And you just started screaming, "Human, human, human!" So those are the things that we want to solve for. That's what LiveKit wants to solve for. And so, if you ask most people in the industry, how do you solve this? Usually, the answer that you're going to get is speed, faster models, lower latency, shave off another few hundred milliseconds. That's usually the wrong answer. So what we're going to talk about is, latency. It's a budget. Rishav was talking about latency as well, right? Latency is very important, but the goal is actually something else. The goal is to be as human-like as possible. We want our voice agents to act like a human would in the moment, and to be able to have the autonomy to do that, right? So we want an agent that will listen while it talks, that knows the difference between you finishing your thought or you still thinking, one that rolls with it when you change your mind mid-sentence, right? And so speed alone doesn't get you there. What gets you there is which models that you pick and how you configure your pipeline. But that's one of the issues that we have, is that nobody can really tell you how to pick the models. There's many, many leaderboards, but they can't really tell you how to pick the models for your voice AI pipeline. And so we're going to talk about how we can fix that. That's the first step, is picking the right models. And so I don't know if we have reactions turned on here or not, or if you can like raise your hands, but usually I do this, like, raise your hands if you've shipped a voice AI to a real user. If you have, that experience that comes with a lot of challenges shipping a real-time agent to production. For everybody else, if you haven't shipped one to production, you have likely talked to one. Have you ever used ChatGPT's advanced voice mode, right? Having a conversation with ChatGPT? Well, OpenAI actually chose LiveKit to power that feature. So LiveKit is the open source real-time framework and infrastructure for human-like agents, agents that can hear, see, and speak to somebody on the other side. So it's not just voice, but also video, data, and even physical AI. We have a robotics division as well. But can you imagine just bringing AI into the real world, into anything that needs real-time communication, whether it involves audio, video, or telemetry. But voice is where it's challenging. So voice is what we're going to talk about today. And so a voice agent is at minimum 3 models working together as one system. So you've got your speech to text, your language model for reasoning, and then text to speech. So there's 3 slots there to fill. I do have to acknowledge that, yes, there are real-time models where you can replace all 3 with one model. But that's a newer concept, and it's not production ready for every single use case yet. The tried and true method is still that cascaded pipeline of 3 models. But the fact that there are these 3 models versus one model, that even adds more to the complexity and more things to choose from. How do I choose the right model, right? And so this is what you have to choose from. There's hundreds of models, dozens of providers. And again, back to leaderboards. Many of us have picked a model just because we saw it at the top of a leaderboard. But that doesn't work for real-time agents because leaderboards, they score individual components. But again, you're shipping a cascade. You're shipping multiple models together as one component. And so there aren't any leaderboards that really score that. And so let's say that your caller wants to book an appointment for Tuesday the 3rd, but your speech to text, here's Tuesday the 30th. So from that moment on, it doesn't matter how smart your language model is, it's now confidently booking the wrong day, and every error flows downhill, and the layers before that, they never knew, right? And so those leaderboards, their scores are based on clean audio and a quiet room, but your callers are on a speakerphone in traffic with kids in the back seat. So these benchmarks, again, they really don't help us on each individual component. We need something that shows us the entire pipeline. And so this leaderboard trap, it is the issue here. But everyone building a voice agent is asking which speech to text model is best, which LLM is best, which TTS is best, right? But the real question is actually which stack should I ship? And so these are completely different questions. And there's not a leaderboard for that. But I'll show you how we can fix that. And so let's just say that you fall into this trap. You pick your models based on a leaderboard, and you start measuring things. Well, this is the first problem that you're going to run into, is that your TTS provider reports time to first byte. And that looks great in a dashboard. Time to first byte, 210 milliseconds. That's really fast. But bytes are not sound, right? So we've measured some popular providers that are shipping hundreds of milliseconds of silence in front of their audio. And in the worst case, up to 3/4 of a second of silence. The first byte came in, but it's still silence before you hear the first sound. And so time to first audio is actually what the caller hears. And so this is what we want to measure. And this is the distinction that we want to understand is measured latency versus perceived latency. And so all of this comes back to simulations and evaluations and testing, and how do you know that your users are going to be satisfied with this latency here, right? So time to first audio is what we should measure there. Language models are very similar. So time to first token is a text metric, but your TTS, it can't start speaking on a token. It needs an entire sentence. And so the number that actually matters is time to first sentence. But models rank differently on that. A model that streams tokens the fastest doesn't always finish a sentence first. So a model that gets time to first token very fast might actually be beat out by a lesser model that finishes the sentence first, right? So the point here is that there are different ways of measuring voice agents versus text agents. And so let's say that you measured everything perfectly. Here's the part that, again, these benchmarks they ignore, is that the agent needs to do things. Every agent has to do something, right? It looks up an order, it checks availability, it books a room, and these tools take time. So 2 seconds, 10 seconds, 40 seconds. or more. And so a model choice isn't going to hide 40 seconds of latency. And so you think about what a human receptionist would do here. They wouldn't freeze while the booking system loads, right? They're going to say, "Give me a sec. I'm pulling that up. I'll be right there. Almost done." Right? So that is human-like behavior. And so why can't the agent just keep talking, keep doing things asynchronously? Well, it can. So here is a code snippet from a LiveKit agent, and there's just one line that makes the difference here. And so this asynchronous await here. So the first update actually hands the mic back to the agent and allows the work to keep running in the background. And so the conversation and the tool just stop sharing a thread. They're able to do things asynchronously. And so what we'll do here is look at one more axis, and this is the actual latency budget. And this actually, no, that's on the next slide. This slide is the pipeline. Some pipelines will wait for the final transcript, and a final transcript that comes in afterwards is too late. So we need to figure out turn detection, right? So turn detection is very important. And so we built a turn detector that listens to the audio itself. Most turn detectors just look at the transcript, the text, and they will still get the best alternative, still cut callers off 9.9% of the time, and ours only 4.5%. And so again, it listens to the rhythm, the pitch, the intonation of the actual audio, and then decides, is the user finished talking? So for instance, if I'm calling to order a pizza on the phone and I say, "I'd like to order a pizza and a Coke," most agents would have cut me off after I said I want to order a pizza because it just saw, "I want to order a pizza." Done, right? But our turn detector actually heard the intonation, my voice, my inflection went up, and I'm not done talking, so it knows to wait. That's pretty cool. Okay, so here's the gap. Here is the gap between the caller's last syllable and the audio that comes back, right? So this gap is what we need to measure. And again, this is time to first audio. So the end of turn detection fires from audio from before the transcript even lands. The language model is already running on a provisional transcript. And as long as we don't change our mind mid-sentence, we're already ahead of the game. And then the TTS starts firing when that first sentence is completed. And so time to first audio, this is that latency budget that we have here. And so if we can stay roughly inside a second and a half end to end, then the conversation still holds. A human conversation, when humans decide turns themselves, it's usually somewhere around 200 to 400 milliseconds. We know when it's our turn to talk, right? And so if you get up to over a second to a second and a half, it still kind of holds. But if we can get closer to 400 or 500 milliseconds, that's when it starts to feel really natural. And so again, latency is a budget, and we need to try to stay within this, but human-like is the goal. And so all of these components in between here and there, those are the things that we have to measure, and we have to measure them right. So if we add all this up, the question at the beginning, which model should I pick? That question was never actually answerable, but we did build something that we wished existed, and that is the benchmark for voice agents. And so what we do is we take a complete voice agent, a working agent, and then we have like a real back end to it, right? We test it completely, and we run hundreds of simulated callers against it. The simulator interrupts them, it mumbles, it changes its mind, just like a normal user would. And then we don't score it on vibes, we score it on outcomes. Define the way that a person doing the job would define them, right? So let's say if it's a hotel reservation booking site, did the reservation land in the database? Did the caller get cut off? Are names and dates correct? Were there invented tool calls? Did it leak any personal information? So human equivalent behaviors. And then completion alone is not enough because completion can be gameable by an agent, right? So we penalize things like did the agent take 10 steps when it could have only done 2? Did it ask questions that didn't need to be asked? And then we swap out the stack. We change out those models, same agent, same scenarios, byte for byte, identical input. And then we create benchmarks against our agent to see which models performed best for this particular agent. But see, the issue there is that the benchmarks that result from this are specific to that agent. So there are as many benchmarks as there are agents then. So you can actually create your own benchmarks. Again, back to these leaderboards, they're based on not real world examples. So you create your own benchmark and you run them against this suite yourself, and you figure out which models work best for your use case. And so the winner, it's not always the smartest model. The benchmarks that we have here is open source. Again, everything that we do is open source. So livekit.com/benchmarks, you can run your own agent against that and see how it performs. And then I'll just skip through this. I like this slide here. The voice agent isn't a chatbot with a speaker attached to it, right? That's what you should take away from this. A voice agent needs to be uh, special built for its use case. And then make it as human-like as possible. All right, so here's a checklist. Latency budget first, measure perceived latency, spend whatever time you have left over on model quality, not speed, that doesn't matter. It doesn't matter if you go down to 100 milliseconds, you still have that budget. You have up to, a second if you need it. Try to stay within 500 to 600 milliseconds. Anything that is a tool call that's going to be more than a second long, make sure that's asynchronous so we don't block the conversation. And then keep testing your components, keep testing your conversation with different components to see which is the best for your use case. And then again, if you want to check out the benchmarks, it's there's livekit.com/benchmarks. And so let me go over into, let's see if there was any questions so far, but I'm going to go over into the actual live demo next.
Uh, Not so many questions on the chat, but I have a question for you.
Yeah, go for it.
So you mentioned that the way that the agent on LiveKit takes turns is by understanding the intonation, and that is when it
Mm.
decides that it can now speak or not. So when you are trying to understand the intonation, does it add to the latency? Because I think other
Mm.
providers they check for the text itself, and when you are checking for intonation, you're checking for audio.
Yeah, so the model that we created, it's a very small model and it actually adds 40 milliseconds of latency. So it does add latency, but it saves so much time in interruptions and making sure that we didn't take a turn when we shouldn't. And so if you take a look at the entire conversation, that 40 milliseconds that's added is actually making it more human-like, saving time overall, and making the experience so much better for the user.
Got it. We have another question in the chat now. How do you take care about sensitive data loss protection?
Sure. So the actual agent itself is not on its own saving any data. And so it is just streaming audio or video or whatever the case, whatever you're using. It's just streaming it. So nothing is actually getting saved. If you obviously, as you're running simulations and evaluations, we have a product called Agent Observability as well. Future AGI probably has some way of saving data as well, because you have to be able to see data in order to see what, like if an issue happened, I need to go back and be able to replay that and see what happened, like look at transcripts, right? So by default, nothing is saved. But if you do have that feature turned on, we actually just released a new feature called PII redaction. And so if you are saving data, before it actually hits the disk, we redact any PII information from the transcript and the audio. So let's say I said my social security number out loud to the agent. The transcript will get redacted and the audio, it will get beeped out in the audio as well.
Got it. So we have the questions flowing in now. I'll maybe ask a couple of questions before you proceed to the
Sure,
next.
sure.
So
Yeah,
how do you handle barge in properly? Like if the user interrupts halfway through TTS, what exactly needs to get cancelled? Like what is going on in the background?
sure. So we have another little small model called the adaptive interruption handling, and what it's like a bargain model basically. And what it does is it's running constantly to understand, is this a bargain or is it not? So for instance, if the agent is telling me something, and I say, oh, okay, I wasn't really, that wasn't a bargain. I was just agreeing with what it was saying. I wanted to keep going. Most voice agents would have saw any audio as a bargain, right? And so our very small model that's running, it detects, is this a bargain or not? If it is a bargain, then if something is running in the background, you can actually set a tool as interruptible or not. So if you, for instance, have, I don't know why you would do this. I'm sure we'll have this in the future, but I don't know why you do this right now. Maybe your agent is running a credit card for you, right? So a credit card transaction is not something that we want to be able to interrupt, right? So you can mark a task or a tool as non-interruptible or interruptible, right? And so if there is a bargain, then it will just stop what it's doing.
And I don't think we are too far from having credit card transactions done by
I
AI.
know, I know. It's just I'm not sure I'm comfortable with that yet, but I have heard of it.
Yeah. So, final related question to this. What does guardrails here look like in real time?
So guardrails, there are because the LiveKit framework, agents framework is open source, you are able to put, adapt guardrails to your use case. You can put them in there however you see fit. A lot of them come down to the actual prompt. So just entering a prompt that tells the agent to do something or not do something. Another way of doing it is actually having a second agent in the background listening to what's going on. And its main focus is to guardrail the conversation or to tell, you know, there's a use case where it's like a Uber clone, and the driver sent the driver sent the passenger a message saying, just cancel this and I'll take cash, right? Well, the agent, the guardrail agent said, no, flagged it, said, no, 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 that's, you can't do that. You're not, it kept going. Sorry. There's many different, the point is there's many different ways of doing it. Based on your use case, it's very flexible.
Yeah, and I would like to add on to that. So, like few months earlier, we also published our Protect guardrailing models, which provide sub 50 milliseconds latency on some of the guardrails that are popularly used in the industry. So, if in case at any time you feel like, there are still things that can go wrong, such as sensitive data or other such things, you can have such models, on top of whatever workflows that you have, so that they will at some point add some certain latency, but you can be sure that whatever is going out to the customer is all protected, right? So it's all open source. I'd encourage developers to check it out.
Yeah. And I don't know if we said this yet, but Future AGI integrates very well with LiveKit. Yeah. Are there any
Uh,
other questions? Let's see.
there are
What should we
more, but
do?
I think we will take them a bit later.
Okay, cool. All right. So what I'm going to do is I'll just briefly show you how quick and easy it is to create a LiveKit voice agent. So, of course, if you don't already have the CLI installed, you can just brew install LiveKit dash CLI. So just brew install LiveKit CLI. Of course, if you're on Windows or Linux, you could just go to our docs page and get the uh, how to install it for that. So after you install it, you'll have the LK command. So LK cloud auth, that's going to then authenticate you to our cloud service. And then LK agent init. LK agent init. And then I'm just going to call this my agent. And then what I'm going to do is use a template. So we have several templates, but I'm going to use the agent starter Python. So we have Python, we have Node, and then we have some other templates as well. So I'm just going to do this LK agent init. We're going to install the dependencies. And then as fast as that was basically it. So what I'm going to do now is just CD into my agent, and then the instructions are right there. So UV run source agent.py, and then dev. And what this is going to do is it's going to run my agent locally, but then I'll be able to go into Cloud here, LiveKit Cloud, and actually interact with it. Let me see. Did I share audio? Let me make sure because let's see. Let me make sure I shared audio. Share settings. Hmm. Well, just let me know if you can or cannot hear this. So it's running right now locally, and I'm going to go to this popped up on my other screen. Let me move it over. Okay. Hello, hello. Can you hear me?
Yeah, yeah, the voice comes in.
Can you hear the agent?
No.
Okay. All right. Let me end that. Let me go to my share settings and make sure. Let's see. Share sound. Okay, there we go. Share sound. All right, let's try this again. So this is, let me just zoom in a little bit, maybe. Not sure how well you can see this. Um, but basically, this is our LiveKit Cloud console. And this is a neat way to test your agent, right? So let's start a new session here with this agent. Again, the agent's running locally. So, hello, agent, are you there?
Yes, I'm right here. How can I help you today?
Awesome. Well, I'm running our webinar. Can you just give me like a one sentence quick, what is the best thing about LiveKit?
The best thing about LiveKit is that it provides an incredibly scalable and flexible infrastructure for building real-time audio and video experiences. Does that work for your webinar?
Yeah, perfect. Thank you so much. That is the one thing that you can laugh at. It's okay. We picked the name LiveKit, but agents get it wrong all the time, and they say LiveKit. Um, that's just the English. English is hard. It's spelled the same but pronounced differently based on the context. So, but yeah, this is our agent console. You can test your agent here. You can deploy your agent. You can see what's going on here. As I scroll down here, you can see which models I'm using. So I'm using Gemma 431B, an open weight model hosted on LiveKit. I'm using Fish Audio S2.1 Pro, which is a really cool TTS model. It has this expressive mode, which we have turned on right now. And then for STT, for our speech to text, I'm using Assembly AI here. And then you can see my latencies here. So time to first token, end-to-end latency. I'm around 1 second. So again, you can run your simulations, your evaluations against all of this, and get that latency down to a human-like latency, so that it you're not waiting on the agent, and it sounds more human-like. Um, and last thing here is what we saw here in the console. You can see that this was actually running here locally. Participant, and it's seeing my microphone. It's bringing in all of these different stats here, so that we can see that this was actually running here. We've got user turn commit. We've got all the logs basically here locally. And then after we're done with this, we can just do LK agent deploy, and this deploys it to LiveKit Cloud, and then you're in production. But the next step is simulations, evaluations, testing it, making sure that it's doing the things that you wanted it to do. And so I think Rishav is going to talk a little bit more about that.
Yeah, thank you. So, all right, let me maybe share the Future AGI platform and we'll discuss a bit more about simulations. Yeah. So as Jesse mentioned that we are very well integrated with LiveKit. So here, as we have built a simple agent on LiveKit itself. This is a customer service agent, and that was built on LiveKit. What I need to do is just select the provider and give a couple of other key details as well, such as the URL where it is hosted and the API key. We auto fetch the prompt chains that you have there, and you can have options such as the call happens through WebRTC or telephony, and you can select between these two. You can choose between inbound and outbound calling, or if the agent speaks first, or if the customer speaks first, right? So all sorts of these different configurations you can provide. You can, of course, keep updating them, and we do the versioning for you. So you can keep testing between different versions and then link them into your production once you are satisfied with how your agent is performing. So here I did the basic agent definition setup. After that, what we do is help you create a lot of scenarios. And Jesse touched upon that a little bit on how you can, you want to simulate thousands of different calls to your agent that you are testing. So we can create various different scenarios. Here we took that agent. What we first do is break it into different workflows. We map out the entire agent and what sort of different use cases it is supposed to handle. Based on these different use cases, we come up with different situations for the customer, which will handle different sort of personas, different age group, whether the customer is in a hurry, whether there are certain other actors as well that are going to join in this conversation. So we control for all of that, and you can scale them to hundreds and thousands of different scenarios. Once you have them, you run simulations on them. This is how that would look like. So I've run a few test calls over here. And once you have run these calls over the created scenarios, you see whether the calls have completed or failed with the status that happened. So either the assistant ended the call, or the customer ended the call, or the call dropped for some or the other reason. So you'll start seeing the status. And once you click inside these, you will see the exact transcript of how the call proceeded, and the conversation as well. You can directly play it from here, and if you want to download, you can download them as well. So you'll start seeing a lot of different metrics over here. And what I want to highlight is that, of course, we provide the basic metrics, such as the CSAT score, the agent latency, the interruptions, the talk ratio between the user and the agent. But you can add a lot of, audio native evals that we have built in-house. So if I go to the add button, you'll start seeing a lot of different evals that you can add to the calls that have happened. So they worked natively on audio. So there is no conversion or loss of signal happening because of audio to text, because we run directly on audio. So here I've configured a lot of different evals that are important for, how to judge conversations between a customer and an agent. So for example, I've configured something as customer agent loop detection, where it detects whether the agent has entered a loop, right? And whether it handled a termination well or not, or it terminated the call abruptly, or whether the call was handed over to a human at the right point of time or not. So similarly, you can set up a lot of different evals that are important for your particular use case and the thing and the KPIs that you are trying to measure. If it doesn't exist on the platform, you can create custom evals as well, based on certain, criteria that are important for you. Once you have run all of this, you'll start seeing the matrix for evaluations. And with each of them, we have associated explanation as well, so you know what is going wrong. But the problem that we started facing is that now it is so easy to build an agent and then configure evaluations through, various different ways. Developers still do not get a very concrete way, or they do not know with all these evals what is one thing that they need to fix in their agent. So we started building analytics for that, and we have something as Fix My Agent. So it'll start giving you pinpointed suggestions on what to improve in your agent. So for example, here it says that modify Dialogflow to trigger a real-time account lookup. So maybe through all the calls, it figured out that the account lookup is not happening. That tool call is either failing for some reason. So it needs modification in the Dialogflow to trigger that real-time account lookup. And similarly, at different branches, you will see like the workflow that was tested and why it was failing, and you can get pinpointed suggestions on how to improve them. So here it says for something like revise the agent's logic to retain better context during pricing questions. So it was forgetting the context, it was maybe not remembering certain details about the customer. And then if you click on the calls affected, it filters out the calls so you can see exactly the calls that have failed in this case. Right. Another thing that I want to highlight on the platform is the observability part. When you're creating the agent definition, you can directly, enable observability over there, and you will start seeing the traces come in. But a really cool thing that I want to show here is that if you select certain traces that are failing for you and then you click on replay calls, here you can use these failed calls to create more scenarios. Now, if certain cases were failing, you just isolate them, create more scenarios, similar scenarios out of them, simulate them through the simulator and understand what is going wrong, make those fixes, and then keep, iterating over those automatically. So all of that comes into one, particular platform that you can use, and you can see how the replayed calls are being affected, how your fixes are now, affecting the agent that you have created. And one other thing here is the error feed that we have created. So this also, based on the traces, provides you automated analysis of what is going wrong in your agent. So, for example, straightforward bookings were escalated to a human where it did not need to escalate it, or something like calls opening in Spanish or English are answered in English. So, the agent is not handling language and dialect very well and not switching between languages depending on the user. If you click for a detailed view, you will start seeing the fixes that you can start making to your agent, and you will also see a cluster of different traces which were the affected traces by this particular issue. So we have really tried to bring it into one place, into a report or a structured manner where you can see all the issues that are there in the agent, and based on that simulate the calls and then make those fixes as well. Right, so it becomes very easy for the developer to understand what is going wrong in their agent and then make those fixes. And all of this is open source, so you can get started with this just today. Just clone the repo and you can start tinkering around with it. Yeah, I think that is all that I wanted to share from Future AGI platform. We have a lot of questions in the chat, so I'll start taking up those questions now. Uh, Rewant is asking, can you explain the gap where a agent live or dies more technically?
Hmm. I'm assuming you're talking about the latency gap. Um, and so, yeah, so you really want to be as close to human-like as possible. So 5 to 600 milliseconds is the target. If you go past, like if you go up to a second, approaching a second and a half, it's starting to fall apart, right? So like that is the max, a second and a half. But the target is 5 to 600 milliseconds. And to technically get there, you have to make the right model choices. Again, if you are using Fable as your LLM, you are not going to have very quick responses. So you got to find the smallest reasoning model that will fit your use case and your needs, that's smart enough, has a good balance of being smart enough and fast enough. And so it really is a lot of trial and error. There's, unfortunately, like I said, there's no leaderboard that says this is the model to use. But you could just trial and error to see which one fits your use case.
Yeah, and I think certain models, so if you're like, this is one of the issues that we were facing with the customer. If your agent is supposed to handle like different languages, there are certain models that are better for certain languages, right? And once you switch between these models, you will start noticing differences in latency as well. So you need to handle them differently if you want to bring down the latency for particular languages and dialects as well. So yeah, a lot of, different parameters, moving parameters that you need to take care of when designing this.
Yeah, there's a question a little bit further down that touches on that. Can LiveKit be used for other languages such as Swahili or French? Absolutely. LiveKit is actually model agnostic. So we don't make any of our own models. Any model that you pick will work with LiveKit. So you pick the speech to text model that works for your language. So Assembly AI, DeepGram, there's several others, right? You look for the model that is compatible with the language that you need. And then same with the text to speech model, right? You pick a model that works for that language as well, and then it all plugs into LiveKit.
Chris is asking, how do you prevent agent from overcommitting? So I think mostly via controlling the prompt, and then heavily using, depending on the basis of function calls and tool calls, providing the right information at the right time. So that plumbing and wiring needs to be well enough. What do you want?
Exactly. No, exactly. It's not as complicated as you might think. It's really just comes down to the right prompt, and then the right guardrails around your tools.
Yeah. In multi-agent pipelines using agent session handoffs, the full chat history accumulates at every hop. By hop 3 plus, this is 3,000 to 5,000 tokens of transcript noise. How are you thinking about context selection at handoff time? Is there a recommended?
Yeah, for sure. Yeah, within LiveKit, we have a way to kind of do like a compression of the context or like a compaction, just like you would do in, Claude Code or whatever. You do a compact, right? We need to keep that like you will find in a lot of voice agents, if you go on like 5 minutes plus talking to a voice agent, it's going to get slower and slower and dumber as you go, and it's going to start hallucinating the longer it goes. Well, that all comes down to, again, to that context rot. And within LiveKit, there are ways to do it. You can also manually, since it's just an open source repo, like you can create whatever functions you would like to make sure that you have the context that the agent needs, but you're eliminating context that is not needed, right?
Yeah, and I think there are a lot of framework these days. A lot of research is also happening around context engineering. So it all depends on fetching the right context at the right time. You do not want to overload your agent with a lot of context that is not required. So just fetching the right context at the right time is important.
Yep, just the key points.
Salil is asking, how do you tune end of turn detection? We have seen agents either jump in too quickly or sit there awkwardly waiting.
Yeah. I'm curious if you've tried our adaptive interruption handling in our turn detection models on LiveKit. Ours specifically are very good at that. If you go to our docs page, our docs are actually very amazing. So if you go to our docs, you'll see the parameters that you can use to tune those. But out of the box, we have them set, the defaults set to where we think most agents will benefit. And so give it a try out of the box and see what you think and go from there.
Okay. Suleiman is asking, most of my clients are in Middle East, and I noticed latency is really high when they try to call the agent from their country.
Yeah, very important that you deploy your agent to the regions that make sense for your users, right? So LiveKit or in our cloud infrastructure has deployments all around the globe, right? So if I deploy to the US West and you're trying to call that agent from the Middle East, then you're going to get really long latency, right? So if the majority of my users are global, then I need to deploy to multiple regions, and that comes down to just basic deployment strategies for any type of application, right? You want your application, whatever, even if it's a voice agent, whatever it is, to be as close to your users as possible.
Yeah. I think we have two similar questions. So, what is the best way to have guardrails like in healthcare environment? You want to make sure medical advice is not spoken by the agent, and latency spikes should also not be there. So, I think yeah, with certain like healthcare environments, you need to be very careful with sensitive data. I would suggest maybe having certain guardrail models that are fine tuned for guardrailing medical advice sort of data. You can have them in place. There will be some sort of addition in latency, but overall it should be better for your application. Jesse, do you have anything to add there?
Yeah, it really just comes back to picking the right models. Again, there are specific models made for healthcare, and with you said, with those guardrails built in. And then there's also speech to text models and text to speech models that are specific to healthcare. So the terminology, all of the hard medical terms and all that sort of stuff, there are speech to text models that are tuned for those to pick up on those, and then same for text to speech models to pronounce them properly, right?
Whale is asking what's realistic end-to-end latency target if you want the conversation to feel natural.
Yeah, back to that 500 to 600 milliseconds. There's really no reason to get faster than that. So pick a model, pick models that will get you 500 to 600 milliseconds, and that's where you should be.
Akshay is asking what's the latest on speech-to-speech live models like real time? Are they production ready in terms of accuracy and cost? I think you touched upon it. Do you want to add anything there?
Yeah, um, they demonstrate well. They sound great. They're fast. Um, and they're getting there. For a basic agent, sure, maybe in production. They have some issues right now with tool calling, with hallucinating, with long context like we talked about. And so for basic use cases, I think I'd be comfortable using it in production, but not for more advanced use cases. Not today, but who knows? Tomorrow there might be a new model that is just blows us away. So.
You can't say. Maybe in a couple of weeks you have something.
Mhm.
Uma is asking what's the best way to reproduce a bad production conversation locally, especially when the issue depends on timing. I think I touched upon it a little bit. There are ways on if you get traces, at least on the Future AGI platform, you can replay directly from there and add to the same scenarios. So you can see the same mistake or the same problem happening again and then start to working towards a fix. But just say, do you want to add anything there?
Yeah, so same on our side. If you haven't deployed yet, then you may not have the data that you need in order to create that. So you can synthesize simulations based on edge cases that you think of, right? So you come up with edge cases that you can. You do the best that you can. But then after you deploy to production and you start running into more issues, right? Then you just add those real use cases to your simulations along with the simulated use cases, and just continue iterating as you go. You're never going to be able to think about every edge case up front. So you'll just start accumulating them over time.
Karthik is asking how are people handling tool calls without creating these huge awkward pauses while the agent waits for an API?
Yep. So back in the LiveKit framework, agents framework, we have asynchronous tool calls. So it will allow the agent to continue talking. Um, for instance, let's say the agent is calling to get you to fill out a form or something, right? And so they're going to ask you a question. What is your name? And then you say Jesse Hall. It has to write that name to a database, right? It's calling a tool to write that name, but it doesn't need to wait on the tool call to finish. It can immediately go to the next question. And if that asynchronous tool call fails or something happens, the agent can go back and say, "What was your name one more time? I didn't quite get that," or something like that, And then it tries again, right? So this is allowing our agent to not have these long pauses while it's doing something. It can continue the conversation.
Is it something that users have to configure or it is provided out of the box?
Provided out of the box. So you can by just defining a tool, if you don't put the await in front of it, then it will be synchronous, and if you put the await, it will be asynchronous. That's it.
And how do you test race conditions around interruption? For example, the agent starts a tool call when the user changes what they want midway. I think
Mhm.
the answer is similar.
Yeah, yeah. You can define a tool as interruptible or not, and if it is interruptible, it should be something that is not important. It's not going to, write to a database or, certain if it's immutable, right? You can allow it to be canceled and it's fine.
Okay. Kevin is asking how are phone numbers provisioned for LiveKit cloud service? Can we connect a Twilio SIP trunk to LiveKit? Can we use GPT and other models as well?
Yep. Again, we're model agnostic. You can use any of the models that you'd like. Right now, my favorite is the Gemma 431B model. It's open weight. It's really fast. It's smart enough, right? It's really really cheap. Um, so yeah, you use whatever models that you want to use with LiveKit, and then I'm sorry, I'm drawing a blank. What was the first part of the question?
Can you connect will you SIP trunk?
Oh, yeah. Okay, so LiveKit has a phone numbers feature, so you can actually get a phone number directly within LiveKit. It is US based only right now. So alternatively, you can use Twilio, Telnix. We have connectors for all of the major phone providers as well. You can manually connect a SIP trunk if you have any other provider as well. Again, we're open source, so it's very open to using whatever it is that you need to use. It's compatible with LiveKit.
Got it. Jesse, we are close to time, but we have more questions in the chat. Do you have 5 minutes to extend?
Yeah, I've got a few minutes.
Okay. So Yash is asking network latency, which is unavoidable. How is LiveKit optimizing for it to keep the response within the desired time frame?
So the big thing, the differentiator, I guess, of LiveKit is the actual infrastructure. So the infrastructure is WebRTC. So most models that you call, they're going to be either HTTP or WebSockets, right? Those are based on TCP. TCP is a blocking network technology. So if a packet doesn't arrive, it's going to wait for all of the other packets. It's going to make the other packets wait until that packet gets there, right? WebRTC is built for media transport, so audio, video, data streams, right? And it doesn't wait. It's non-blocking. So if you think about that in an audio transmission, if a packet is missing, you're not really going to notice it. If a couple of packets are missing, you might hear a little blip, right? But it's just going to continue on. So that's how we get things to go so fast, is because we're not the technology, the underlying technology is fast.
Can we connect agent to knowledge or database? How much limit Future AGI is giving on the free version? So yeah, on the Future AGI platform, if it's related to that, yes, you can connect your databases and knowledge bases, even for the simulations that you're trying to do. For the limits, so there's no limit on the databases and knowledge base. The platform is completely open source. There are limits on the AI evaluations that you add, but you can try the open source version, and I think most of your requirements should be met there. Jesse, I'm not sure if it is related, but can you connect knowledge bases or databases in agents?
Absolutely. Every agent needs context. So you have to bring that context in from somewhere where it's saved, right? So if you have a Postgres database somewhere, a Redis, a MongoDB, or whatever it might be, that connects right into your agent in LiveKit. Very easy to wire up. You can just look at our docs. We have a docs page on how to do that.
Is the adaptive interpretability model open source?
Yeah, the model itself is good question. The model itself is free, but I don't know if it's open weight, open source. I'll have to get back on that. But if you use it on LiveKit Cloud, it's free. We don't charge for it.
What are your thoughts on processing TTS in scenarios where folks speak a mixed language? For example, Puerto Rico, people speak Spanglish, where you think I should optimize for?
Yeah. So again, this is back to model selection. I think Google Gemini, it has a really good model where I think I did a demo on that where I would speak some Spanglish as well, and it picked up on it just fine. So it's just back to testing different models to seeing how they adapt to it, right? So some models are really good, some are not.
Lakshya is asking, how do we come to know when to cut the call? Like users can try to game the AI voice agent. How do we handle these situations? I think you can have certain tool calls around loop detection or intent detection. And if those criteria are met at certain points, you can think of disconnecting the call. But Jesse, what do you want to add?
Yeah, you can add a tool for your agent to just say, a certain scenario happens or whatever, just hang up.
For live agent, how to make sure agent follows actions in sequence, especially if it has a large system prompt.
Mm. Yeah, very, very nice. So again, back into the LiveKit agents framework, we have something called workflows, and workflows is just that. So let's say you have a form, back to a form. You've got 10 inputs in this form that need to be filled out. This is not a visual form. This is all just in code. It's just we're collecting data, right? So a workflow allows the agent to step by step collect information or do something, right? And it makes sure, and it doesn't, you can specify it needs to be in the specific order, or you can specify in any order. And so the agent just makes sure that it follows that workflow that you've designed for it.
Okay. So we'll take the last question. How can we simulate packet loss, jitter, bad microphone, noisy rooms? So at least on the Future AGI platform, we provide configuration for all of these, and you can decide to have them as on or off toggles. So we provide noisy rooms, bad microphones, network latency, and all of these things you can simulate on the Future AGI platform. And
Awesome.
so, okay, with that, I think we'll close. Jesse, do you have any parting thoughts for the audience?
Just appreciate it. Again, everything we do is open source, so give it a try. And we love to hear feedback on any issues. Our engineering team is actually super responsive. Any issues that you have, we will likely have a PR in today to fix it. So
Awesome. So yeah, I think both the platforms are open source, so do give them a try. And Future AGI is available on our Discord, so please get in touch with the engineers. We'd love to talk to you.
yeah,
Thank you so
sounds
much,
great.
Jesse,
Thanks.
for joining us.
All right. Thanks, everyone. Bye.